Hi, welcome to the portal. In this video we are going to learn how to find the determinant of a matrix by row reduction. So as we have learned how to determine a determinant by other methods, so this is the last method that we are going to use to determine a determinant of a matrix. So now before we can go through with it, let's check a simple theorem. Okay, so now let A be a matrix and B also be a matrix. So but B, it is a matrix that results from the operations of A. Okay, so meaning that B, it is a matrix that results when operations are being performed on A. Okay, so now this whole theorem wants to explain, or let me say it gives the guidelines to what happens when we perform the operations on a matrix. Does the determinant get affected or not? What operations affect the determinant and which operations do not affect the determinant? So we are going to learn about that here. So if you can check here, we have point number 1. It says if a multiple of a row is added or subtracted to another row, then the determinant of A, which is the original matrix, is equals to the determinant of B, which is the matrix that resulted from the original matrix when it is being operated. Okay, so meaning that when we add a multiple of, for example, row 1 to row 2, then there's no effect on the determinant, so the determinant remains the same if we do that. Okay, so number 2, it says now if rows of A are interchanged, then the determinant of B is equals to the negative of the determinant of A. Okay, so now this one affects the value of the determinant. So if, for example, I have row 1, I interchange it with row 2. For example, let's say this is a matrix. I have 1 0 0, and then here I have 0 0 1, and then here I have 0 1 0, and I want this matrix to be in what? To be in row echelon form. So I would have to interchange these two rows. So when I interchange these two rows, if this was the matrix A, and then now matrix B would be what results from this from this operation. So I would have 0 1 0 and then 0 0 1. Okay, so now the determinant would be negative. Okay, so will not be the same. So when we interchange the rows, the value of the determinant will be affected. Okay, so okay, I think I erased something there. Alright, number 3, it says if matrix B is obtained by multiplying matrix A with scalar k, then the determinant of B is equals to k multiplied by the determinant of A. Okay, so it means now if we, for example, we take out a common factor out of a matrix, so that common factor, we are still going to count it that it will also multiply the determinant of that remaining matrix. For example, okay, so now let's do an example and see how we are going to apply this. Okay, so let's look at this matrix. So this matrix is the matrix that we've been using to determine the determinants. So let's use this one, okay, to perform the operations. Okay, so now we know that okay, so we know that the determinant of A, it's simply this. It's simply like this: 175 negative 1 1 0 3 2 1. Okay, so we are going to perform row operations on this matrix. Okay, so now the aim of this method is to create a triangular matrix. Okay, so is to create a lower triangular matrix. Okay, so now what am I going to do from here? So I will say here, I can see that, oh, if I say row 3 minus 5 times row 1 to give me new row 3, what am I going to get? Okay, so I'm going to get, so this one remains as it is: 1 negative 1 and then 3 7 1 2, and then here, so because I say 5 minus 5 times 1, which is 0, so 0 minus 5 times 1, 5 times negative 1, so that minus minus, it gives us a positive. Okay, so now it means it's 0 plus 5, so which is 5. So now 1 minus 5 times 3 is going to be 1 minus 15, so which is negative 14. Okay, so remember now that this thing, it's the first one that says if we add a multiple of a row to another row, there won't be any change of the determinant. Okay, so now let's continue. Okay, so another operation, let's say now let's take row 2 and minus 7 times row 1 to get the new row 1. Okay, so what are we going to get? Here we are going to get, okay, this one still remains the same. Then here we are going to get 0, right? And then so here we'll have 7 minus minus into negative 7. Okay, so now it means now we are going to get 1 plus 7, which is 8. Okay, so now 2 minus 21, negative 19. Okay, so here we still have 0 5 and negative 14. Alright, okay, so let's continue now. So from here, what else can we do? From here we can say, oh, we can take out 8 as a common factor and 5 as a common factor as well. So if I say now let's divide row 2 by 8, so I'm taking out 8 as a common factor, so I'm going to say 1 over 8 r2 to give me the new r2. Okay, and then here I would say, but let me write it here at the bottom. Okay, so I would say 1 over 8 r2 to give me the new r2, right? And also I want to do double operations on the same thing, also 1 over 5 r3 to give me the new r3. Okay, so remember that I'm taking out 8 and 5 as a common factor, so because I'm taking them out as a common factor, I'm going to write them here. So I'm going to write 8 multiplied by that 5 I took out as a common factor, and then here I'm going to have 1 negative 1 and 3, and then 0 1, and then here I have negative 19 over 8, because here on this row I took out 8 as a common factor, and then here I have 0 1, here negative 14 over 5. Okay, so now from here, what happens from here? Okay, so from here I can see that, oh, I can minus I can say r3 minus r2, r3 minus r2 to give me the new r3. Okay, so and then also I can say okay, let me just write it here. So that 8 multiplied by 5, and then here we have 1 negative 1, and then 3, here I have 0, and then 1 negative 19 over 8. So here I'm going to have 0, and then here I have 0, and then remember I said row 3 minus row 2, so we'll have negative 14 over 15 minus into negative 19 over 8. Okay, so which gives us negative 17 over 40. Negative 17 over 40. Okay, so now from here I'm going to add row 1. I'm going to add row 1. Yes, row 1 to row 2. So I can do that. But I don't need to do that because I already have what? A triangular matrix. So from here I can say that, oh, I can now calculate the determinant of this triangular matrix and multiply it by this way. So I would have 8 times 5 multiplied by, remember, the determinant of a triangular matrix, it is the product of the diagonal entries. Okay, so the diagonal entries is 1 multiplied by 1 multiplied by negative 17 over 40. Okay, so 8 times 5, we know that it's 40, right? And then here we have negative 17 over 40. Here 40 cancels 40, then we are left with negative 17. Okay, so now this is the answer that we've got in other problems. So you can check it on the link on your top right. Okay, you can compare it with the other problems that we have done using the other methods. Okay, thank you guys. This is how we do how we find the determinant by row operations. Thank you.